useful, very simple function called coalesce. The hardest thing about this function for most people is remembering the spelling. So coalesce is a function that can take multiple arguments, and what it returns is the first argument with a non-null value. So it's used to handle null values. Why would you need to handle null values? Different reasons. Here are the common use cases. Data validation. Maybe you want to replace a null value with something meaningful. Maybe you need to calculate something. So in calculations, normally you would convert null values to zeros. Otherwise, the calculation will not run. It will not take place. And data presentation. So if you have empty cells, empty columns, maybe you want to replace them with some default values for cosmetic purposes. All right. So this is another one that is a fairly simple piece of code. So I don't want to write it from scratch. So let's see what the requirement is. Find out all the employee ID, first name, their manager first name, and manager ID. Employees who do not have a manager or they are highest in hierarchy, assign manager as their columnar value for manager name and X as manager ID. So let's repeat this. Sounds a little bit complicated. So we have one table, employees. Some employees have managers or are managers. Some employees don't have managers. Other than retrieving some regular columns like employee ID and employee first name, right? We want to get their manager ID, right? If they have a manager. If they don't have a manager, it says get X as manager ID, right? And we want their manager first name. What does it say? To be just manager for the manager name column. So since we're dealing with employees and managers, we have one table. This is mostly a familiar example for those of you who went through the self-join lesson. So we have to join the employees table to itself, right? So we have employees. We gave them the alias E and M to distinguish later on in the select part, employees and managers. We're making sure that when it comes to managers, their ID is the manager ID of this employee. So this on statement is really important. So if you think about it on like a singular level of one employee, one manager, it's easier to comprehend. So if we're dealing with one employee E who has a manager M, and we're joining it, and we can say that M, so manager, employee ID means their ID because employee ID is the identifier of the employee column, and M is still the employee column. So this manager is the manager of this employee, right? So that's how we're joining these two columns. Just a little bit of a refresher on self-joins for this use case. Back to the question, employees who do not have a manager. Okay, so what happens if an employee doesn't have a manager? This is the employees table. If an employee doesn't have a manager, their manager ID column, that cell for that employee, for that row, will be empty, will be a null value. So employees who do not have a manager or are the highest in the hierarchy. So again, they don't have a manager, same thing. Assign manager as the columnar name for manager name and X as manager ID. So that's what we're doing here. So X as manager ID. We are creating a new column called manager ID. And the coalesce reminder, the coalesce returns the first non-null value in the list of their arguments. So if we're dealing with someone who, if we're dealing with someone, what does it say, who not have a manager? Something's fishy to me. Let me just check the solution. Employee ID. Okay. Employees who do not have a manager or are highest in the hierarchy. Okay. So in case the employee ID from the M employee, right? So in case m.employee ID, which essentially is e.manager ID, right? Put X, right? In case this is null, set it as X, right? And in case the manager doesn't have a name, again, the manager doesn't exist, put manager as their name. One thing that would make this more intuitive to me, like this works, but instead of putting M employee ID being null in this case, what would make it more intuitive to me would be E.manager ID being null. Unless I'm missing something and this ends up not working. Let's run this. Okay. I think this just makes, both are correct because E.manager ID needs to be equal to M employee ID. But let's get back to the main requirements here. Employees who do not have a manager. So those are employees where manager ID is null. Put X as manager ID, right? So we are coalescing employee.manager ID. We're setting it to be X, right? And this will only be X if this value right here is non-existent, it's a null value. Also, if the manager doesn't exist, put just manager as manager name. And I want to have a look at the output. So Michael doesn't have a manager. Manager ID is X. Therefore, we cannot put a manager name either because that's also going to be a null value. So we just put manager to indicate that Michael himself is a manager. He's highest in his hierarchy. Same for David. And let's see if we have some more. So Michael and David only. And we can see that Michael is the manager of Karen. David is the manager of Daniel. David is also the manager of Emily, and so on. So I purposely kind of changed the solution just slightly here to make more sense, at least to me. So that's what we did. I wanted to show you another use case of coalesce. It works the same way. I wanted to show you a computational use case, a computational use case of coalesce, because this is more cosmetic. If we don't do this, we would just get empty cells. Like if we don't coalesce manager ID, we would get an empty cell, right? A very needed and practical use case of coalesce is when you are dealing with computations and you fetch something that might be a null value and you're trying to do some maths with a null value. You won't get an error. It just that row will be ignored. So I want to leave you with this. So I added a comment here that I'm going to explain. All right, you're going to have to use your imagination. So let's say you're dealing with a database in a bank, and you just have two basic tables, accounts and transactions. So accounts are regular dimensional tables where you have the account holder name, account number, and maybe you have the initial balance there. All right. Then you have transactions. Transactions happen all the time. So you take money out of the account, you spend, you make deposits. So credits, deposits, withdrawals, so on. So as I said, you have two tables, accounts and transactions. Let's say your task is to determine what the final balance is of a person after all of their transactions have taken place. And you know that this is like a very special use case, that all transactions have been withdrawals. So every transaction just deducts the amount from the initial balance. So as I said, the initial balance is stored in the accounts, okay? And transactions have certain amounts. So that's the transaction amount. If you sum all the transactions, right? Now that would have to also have like a group by if you're doing it on customer level for each customer. I don't want to get too much into this. The point of this example to show you a real world use case for when you need coalesce in a computation. So just focus on summing transaction amount by each customer. So that way you get how much money they spent. And you'd know from their initial balance how much money they had in the first place. That's how you get the final balance, right? Except, what if someone has had no transactions? They just made their initial deposit, it's stored in their account table, they haven't made any transactions. In that case, t.transaction amount will be null. All right, it will be null. And if you do sum null, nothing will happen. That row will be skipped. So your whole output will only contain those people who have had transactions. So what you're going to want to do if you're dealing with numbers that can potentially be null is coalesce them to a zero value, because zeros can be summed. So if you sum zeros, that's a zero. Initial balance minus zero is initial balance, and it's the same as the final balance.